Hello, my name is Thinh, and my student ID is 229552525, and this is my student ID card. Yes. Okay. Today I will present my solution, my assignments about programming. And so I will show you my solution. Let's begin now. Task one, okay? Yes, that was require me to create a work class. So to present each work in a lexicon. Okay, each work object needs to store three things: the word spelling, its frequency, and a list of neighboring words. In the constructor, I store the word in lowercase to ensure case intensive operation. The default frequency is 1 because the word should appear for the first time when the object was created. The list of neighbors were empty and will be filled in task 5. Frequency and as neighbor function increments this one and frequency function increment for the frequency by 1 each time the word appears again in the file, and the neighbor function, yeah, enable reward to the list. Yeah, comparison. This one is comparison methods. Allow Python to compare two work directly using operators such as less than, greater than, something like that. Without them, the sorting algorithm in task 3 will be through type error. I will test this example. Task 2. In step 1, I initialize the lexicon. I use an empty list to represent the lexicon. This list will contain the work objects after reading data from the file. Step 2, I write the read data function. It takes the lexicon and the file name as input, then reads each line in the file. For each line, I use split here to split it into tokens based on white space. For each token, I use list comprehension to retain only alphabetical characters using its alpha to remove on punctuation and numbers. And then I convert it to lowercase. If after cleaning the work, if it becomes an empty string, for example, the token is the number 1. So then I skip it. I iterate through the lexicon to check if the work already exists. If it does, I call a frequency function to increment the count. If not, I create a new work object and append it to the lexicon. Here. Step 3, calling the function for three files. I call read data 3 times for the three files in 0, in 1, and in 2. So I have an example here run. Here. Task 3, sorting algorithm. The first algorithm I chose is bubble sort. The reason I chose is because it's simple, easy to understand, and suitable for the requirement. Uh, Implementing it in poor Python without using built-in sort. Yeah. Here, I use bubble sort. The outer loop for outer loop I runs n minus 1 time. Each loop brings the largest remaining element to the end of the list. The inner loop tray compares each adjacent pair. If the left element is larger than the right element, it swaps them here. I roll lexicon tray greater than the lexicon tray plus 1. Python will automatically call the treaty method of the work class in task 1. I will show you that task 1 here. This is the treaty function. Okay. Yeah. It compares the alphabetically. The function sorts in place and doesn't return anything. The second algorithm is the hybrid sort, compiling merge sort and insertion sort. I set threshold to 10. You can see that this is a threshold. When the subarray has 10 elements or fewer, we use insertion sort, otherwise use merge sort. The insertion sort function takes the lexicon left and right in this and sorts that segment using standard insertion sort, getting the key, shifting larger elements to the right and placing the key in the correct position. And merge function compiles the two sorted half. I copy the two half to left part and right part and use three pointers IJK, compare and write them back to the original lexicon in order. And the hybrid sort helper function is recursive. If the segment size is less than or equal to threshold, it calls instruction sort. Otherwise, it splits in half, recursively merges the two halves, then merge them back. The hybrid function is the main function, taking only one parameter, the lexicon, as required. Task 4 creates a small problem for the user to choose a sorting algorithm. I use input to display the correct question as required. If the user enter 1, print a message and call purpose sort. If they enter 2, call hybrid sort function. The problem states that we can assume the user will always enter 1 or 2, so I don't need to handle the case of incorrect input. So before running task 4, I must run task 2 again to reset my lexicon to its unsorted state. Okay, task 2 here, my solution. Run it, move to task 4, my solution, and run it. So example, I press 1. Yeah, it's been sorting with purpose sort. Run again. 2. Sorting with hybrid sort. Task 5. Populating neighbors. Task 5 requires identifying and storing a list of neighbors for each word. A neighbor is a word of same length and different by exactly one letter. Its neighbor function check two conditions. The first condition, same length. If different length, it returns false immediately. The second condition counts the number of positions with different letters using variable diff. If diff exceeds 1, it exits early. Finally, it returns true only if diff equals exactly 1 here. In such a short neighbor, the problem requires the list of neighbors to be sorted alphabetically and prohibits the use of built-in sort. I use insertion sort for the list string, the same logic as insertion sort in task 3, but apply to strings instead of work object. And add neighbor, the add neighbor function iterates through every pair of works in the lexicon using a double loop for each pair of different I and j. If its neighbor return true, it adds work to j to the list of neighbors of work I. After checking on j for work I, please choose the list of neighbors of that work. Here's my example to take test. Okay. Task 6 writes the entire lexicon to the file out.txt in a required format. The write data function opens the file in write mode, iterates through each word in the lexicon, and writes a line in the following format: spelling, spaces, frequency, spaces, and a list of neighbors. I use app string with word neighbors. Python automatically brings a list of string in the correct square bracket format. Like for example here, the lexicon is now sorted from task 4, so the output will be automatically alphabetically ordered. So I have completed on 6 tasks of the assignment. In summary, task 1 creates the word class, task 2 reads data into the lexicon, task 3 implements two sorting algorithm, task 4 lets the user choose an algorithm, task 5 calculates neighbors, and task 6 write the neighbor to the file out.txt here.